What is the universe made of? One answer is the universe is made of elements, like carbon and oxygen. But then, what are those made of? Elements are made of positively charged protons and neutral neutrons, being orbited by much smaller, negatively charged electrons. Electrons are fundamental subatomic particles. They interact with larger particles like protons and neutrons, but they cannot be broken down into smaller particles like protons and neutrons can. Protons and neutrons can be broken down into particles called quarks. Protons are made of 2 up quarks and 1 down quark, while neutrons are made of 2 down quarks and 1 up quark. Quarks and electrons are a type of fundamental particle called a fermion, which, along with the fundamental particles called bosons, make up what physicists call the Standard Model. The outside circle are the fermions, which are the building blocks of matter. The inner circles are the bosons, which are force carrier particles that create the different forces of the universe. These particles are the fundamental particles of the universe, which begs the question, what are they made of? While these particles can't be broken down into other particles, there are many theories that suggest what else they might be made of. One of the most well-known and accepted theories is string theory. More specifically, a version of string theory called M-theory. The basic idea of string theory is that each of the particles on the Standard Model are made of what's called a quantum string. Quantum string is really small, around 10 to the negative 33rd centimeters actually. That's a lot of zeros. Quantum string is so small that it can't be directly observed, so if you tried to look at it, instead of seeing string, you would just see the fundamental particles the string represents. If it were possible to see the string, you would see either a circle or a line. These are called closed loops and open loops. These loops of string vibrate across all dimensions, although they are themselves only one-dimensional. Based on what type of loop they are and how they vibrate, a string can present itself and have the properties of any of the fundamental particles of the Standard Model. There are 5 main types of string theory, each involving different types of string, vibrational patterns, and mathematical symmetry. Type 1 allows open and closed strings and uses a form of symmetry called O32. Type 2A has symmetrical closed strings and open strings that attach to odd-numbered D-branes, which are membranes that interact with quantum string. Type 2B has asymmetrical closed strings and open strings that attach to even-numbered D-branes. Type HO, named for its symmetry type, uses only closed strings. The left-moving vibrating strings act like bosonic theory, one of the first types of string theory that only involved bosons. Right-moving vibrating strings act like type 2 strings. This type of string theory uses O32 symmetry. Type HE is mostly the same as HO, except it uses E8 by E8 symmetry. These 5 types of string theory require the existence of 10 dimensions. Most people know about the first 4 dimensions, the ones we live in. The first being length, the second being height, the third being width, and the fourth being time. While the other dimensions are hard to describe conceptually, we can more or less prove they exist with mathematics. M-theory, however, uses an 11th dimension to connect all 5 theories into one single unified theory. A good way of thinking of this is to think of 5 travelers, who all want to get to the same destination. They find 5 different paths, and each traveler picks a different path, all of them thinking that their path is the right one to get to their destination. Really, the 5 different paths are different ways to get to the same place. In this analogy, the 5 travelers are quantum string, the 5 paths are different types of string theory, the distance the 5 paths go are the first 10 dimensions, and the destination is the 11th dimension. M-theory is one of the most accepted and most likely theories on what the universe is made of, and, therefore, what we're made of. So now that you know about string theory, you can start wondering about the next question that will surely plague physicists in a few decades. What is quantum string made of?